this program to print out how many seconds left to go. That's what our program's going to be. So let's start writing our C program, and along the way we're going to see that we need a function. So our C program begins with a comment, and it's going to be called countdown. What about that? I should call it countdown. Seconds till the end of the assignment. And Richard Buckland, missing a what? Oh, it's all right. It's all right. It's all right. I'm allowed to make spelling mistakes. Richard Buckland, date is 19th. Thank you very much. 19th of March, 2008. Okay, and let's go int. Oh, we could try putting void main, and we'd see it would all work. And but let's not even go that way. Okay, but at the end, remind me before we finish today. We'll just change it from int to void, and you'll see it'll still all work. Because the compiler and the operating system, I'm not sure which it is that picks up the slack here. One of them is going to pick up the slack and cover for us if we get it wrong. Int main, int arg c char star arg v. Okay, and let's always put our closing brace in. And now we're going to say how many days to go? How many whole days to go? We should put some J's in there. Just to give it that authentic Viking feel. You notice not many words in English have J in them. And that's because around like 1000 AD, the Vikings came and stole most of the J's from England. Okay, and then we're going to, now we're going to have a number that's how many days to go. I'm going to have to declare it. Where's a good spot to declare this number? I could decline it. There's two spots I can declare it. One is I could just do it here. What am I going to call it? Should I just call it X? No, who does maths? Okay, have you noticed when you do maths, whenever they write formulas, all the variables have single letter names. And that's because all the mathematicians secretly want to be computer hackers. And their idea is to make the maths as small as possible. And if it can be really small and really obscure, in fact, there's a trick we do when we do maths, which is if you go through and finally prove something, then you go back, you burn all the working you've done to prove this thing, and you go back and you write it backwards. So no step is obvious till you get to the last one. It's like a bottom-up proof, even though you prove it top-down. And then you make it as obscure as possible and that's what maths is about. So when you're writing maths, if you wrote down, if you wanted to calculate the area of something and you said length times breadth, they're just going to look at you. But if you said x times y or L times b, they're going to love you. But in computing, it's the opposite. Single letter variable names mean nothing, so let's not use them. Let's not call it x, let's call it what? Yeah. J's left. Okay. So you've got to be careful. Like, it was really fun to be funny. I completely like it. But in your programs, something that seems funny now. See, there'll be a time that you've written the program and you've passed on to someone else, and they'll be in the middle of the night trying to program and it won't be working, and the boss will be shouting at them, and the space shuttle's about to lift off and the enemy tanks are rolling in, and they've got to get it working in 5 seconds, and they've been working on it for 3 days, and their kid's birthday, they're about to blow out the candles, and they're still locked in their room trying to solve it. And then when they suddenly work out, oh, I just got the variable name wrong because you used a funny one. It's like when your program does something wrong and you print an error message out, you could print an error message out saying, that was pretty stupid, sucker. And that seems really funny when you write that. But when it's someone using Microsoft Windows and they've just lost their entire thesis, and Microsoft Windows pops up a message saying, stupid sucker, they're not going to be in the same witty frame of mind that you're in. So you've just got to think, when you do this stuff, I reckon keep your programs pretty serious. Let's not have any humour in it. There's a negative humour flag we can use for GCC. We should put that in all the time. Okay, so int days left. So one place we could declare it is here. Or we could declare it right at the top, at the beginning of main. It doesn't look, here there's only one line difference, yeah, it doesn't make much difference. But let's just look at the philosophical difference between the two. In the old days, we used to declare everything at the beginning of the block that it was used in, so the function it was used in. And that was really convenient, because if you're in the middle of your long function and you suddenly come across a variable and you want to know what type it is or where it's declared or you want to know something about it, you need to look at its declaration. You know where to look. You think, oh yeah, I just have to go to the top of the function, it'll be up there. So it's very convenient for finding things. The disadvantage, what's the disadvantage of declaring it up at the top? That's a really good advantage, but there's a disadvantage that goes with it, yeah. It gets really crowded, yeah, and sort of related to that, if I could say it in another way, if your function's quite long, say, and later on we'll see we shouldn't really write long functions, but suppose you've written a long function, and you've declared something up here, and you're using it down here, there's a lot of space. If you're reading it a bit like a poem or a book, you're reading someone's program, you don't really sort of ever want to have to go back. It's really nice if something's declared right near where you're going to use it, so you don't have to think, oh, and that was where? And you have to page up to find where it is. So it's convenient to declare it where you use it, and it's convenient to declare it in a known spot near the stop. So the rule we sort of have in this course, well, I think we've even said it in the style guide, is if you're just using it in one spot, declare it near that spot. And if you're using it throughout, so you're using it everywhere, then declare it at the top. So wherever you are, you know where to find it. So the rule then is when you see a variable and you want to know where it's declared, you either look immediately above where you are, or if it's not there, go up to the top of the program. Does that make sense? We're going to be using this throughout, so I'm going to declare it at the top. So int days left, how many days are left? And then we're going to, it's not yet initialized, that's okay. Scanf, some people will tell you you need to initialize everything when you declare it, but that's not what we're going to do in this course. And ask why, or ask your tutor why, if you're interested in that. Scanf, we're going to read it in, how many days to go, and what are we going to call it? Oh, we've already called it days left. What's that? Thank you. If you forget the ampersand, what did we notice? Did anyone write that up on the wiki yet? Can someone that remembers what happened when we left the ampersand write it up on the wiki? Maybe set up a wiki page called mistakes in error in lectures, or error compilation mistakes or something. Because if we had one page with all these error messages that said this appeared when Richard did this, then one day when you're running a program and you get that error message, you could go to this page and it would say, oh, that happened when Richard did this. I wonder if that's because of this. So it'd be a really nice lookup that goes from error message to possible reason. That's a really nice thing to have. Yes?
How about we write the page in such a way that every time when we're looking up at our compilation errors and we think, what does this error mean? We can look it up on the page and say, what is it actually trying to tell me?
Yeah. You mean expand it further, not just what I was doing, but an explanation of it. Yeah. I think that's awesome. Yeah. Some sort of page that's a help to you guys, because you will get error messages, and that's the only hint you've got to go with to tell you what's going wrong. It'd be really nice if you could go somewhere that would give you some hints as to what the error message might mean. Because sometimes they're a bit cryptic. Yes?
Big suggestion that if somebody does make that page and you get an error message that you don't understand, post it on the wiki page without an explanation.
Oh yeah, everyone just post it on, and even if you don't know what's going on, post the error message on, that's what you're saying, and someone else will say what it means. That's a brilliant idea, and that way you can all help each other. Or no, better on the wiki, I think, because it's better to keep don't you think? Not everyone reads the forums, they get a bit crowded and there's lots of messages. And if it's one simple wiki page that was high quality, I think people keep using it. Yes?
You didn't foresee where to find printf. You didn't include at the top.
Oh, thank you very much. Thank you. Hash include. There we go. Now it'll know all about printf and scanf. Okay, now we want to now print out. And so I'm going to do this as a top-down design. There's a hard bit that's happening now where I've got to work out how to convert days into seconds, and that's hard. So I'm not actually going to do it. My top-down design is just say some magic happens. And I'll say days are converted into seconds somehow. That's what happens here. Because I just want to get the overall structure of the program right. And I don't want to get bogged down in little details. That's the bottom-up way of doing things. I'm just assuming it happened, and then obviously I have to print it out. And I'll print out, you have, oh, come on, let's not be stressful. Only %d seconds left. And if we could have some sort of little digital, that'd be cool, but we can't. Like a bomb in a fifth element or something. There's not enough J's. I don't think is there anywhere here we could put J? F's often go well with J's. It looks stupid. Before the F? Okay, so there we go. So it's going to fall off the edge. It's going to wrap around soon. So if I was at home writing my assignment, I wouldn't be using Pico. There's like 3 different ways you could write your assignment. One is you could just come into the labs and write it here. Easiest. Use all the software in the labs, use everything, it's perfect. Step 2 is you want to be lazy and write at home. You could write it at home and use SSH, or PuTTY, that is, to come in here and remotely with 2 windows, like I'm doing now, do that. But that's a bit of a pain too, because PuTTY's such a bad editor. The third, all these ways are increasing in convenience, but of course you have to do a little bit of work to make each one work. The third way of doing it, hopefully you're up to, you can do the first 2 yourselves. The third way of doing it would be to get a decent editor at home, like Context or something else. It doesn't matter what it is, not WordPad, but something else. Because WordPad, I don't know if it saves it as an ASCII file. I have a funny feeling it doesn't. It does. But it might do something weird. It lets you format or font or...
There's a Notepad++ which has the syntax.
Okay, so there's something called Notepad++ you could use as well. Yeah, and maybe whack that on the wiki. There's a page where I've listed editors you could use. Maybe you could add that to that. So get an editor, either Context, which is freely available, or search around for other ones, because Context development work, I think, stopped last year and it's been sold to a company. You can get the old free version, but who knows what's... So, you know, there might be better ones out now. But certainly Context is good enough. That means you could edit the file at home, and it's much more convenient. You don't get these line wrappings and things happening. But the problem is then you're at home, and you want to compile it, and presumably you've got to compile it at uni. So then you've got to transfer the file to uni to compile it, and then you'd compile it using PuTTY. You'd log into uni and type GCC. How do you transfer the file from home to uni? 2 ways. Dumb way is open a PuTTY window and just paste it in. You know, cut and paste all the text. That would take you forever. Don't do that. But you could in Crisis if you're trying to submit and all other ways are failing. But the best way is using WinSCP, which is again another program you can download from our front page that opens up 2 windows, one showing you your directory, like Windows Explorer, one showing your directories at home, one showing your directories at uni, and you can drag files between the 2 and move them between home and uni. So you could edit the file at home, move it to uni, and remotely compile it using PuTTY. The fourth and most ultimate way of doing it is you could edit it at home using Context, say, and then compile it at home if you had a C compiler at home. And if you're using the Mac, you've got a C compiler already. It's just in Xcode. You might have to reinstall Xcode or something because it's not always installed by default. If you're using Linux, it'll come already. If you're using Windows, it doesn't have a C compiler that comes with it. You should use Cygwin, which you can download from our course homepage to emulate Linux, and that comes with GCC. That's slightly fiddly, and we're not going to teach you how to do that till after the break. But you could fiddle around with that if you wanted the ultimate luxury and convenience, being able to do everything from home. You could experiment with it, but whatever you do, don't do that at the last minute and have that as your only strategy. I'd pick one of the other ones. Yeah.
You can also do a graphical.
Oh yeah, then the last one is you could Vim it or something, but not Vim, the VNC it or something. Yep. And there's some threads on the forum for how you can do that. You can actually turn your home terminal into a dumb terminal connected to the uni machine, so it's exactly like a lab machine. That's probably the hardest of them all and the heaviest on your bandwidth, I expect. Yeah, so let's look at that after the break. You're welcome to fiddle with all of those. We've taught you the first 2 already. I reckon you can work the next 2 out yourself. I reckon you could work out how to use WinSCP yourself, trivial. And if you fooled around with Cygwin, you might even be able to get that to work by yourself. Yeah.
What version of GCC?
What are we using? I don't know, 4.01 or something. I don't know. You type GCC minus version or whatever it is here, and you'll find out. I'm not sure what version we're running. But because we're using such vanilla stuff, it won't matter. You could use any version of GCC and you'd be fine. Yeah. Okay. Okay. Shh. So that's how we set it all up. But now let's do it. You have only this many seconds left. Because of line wrapping, I've gone to the next line. And what's my variable going to be called for how many seconds are left? Seconds left. If I called it seconds, what would you think of that?
Fine.
It's fine because it's clear. But there's a problem. What's that?
It might be already defined.
It might already be defined. Oh, yeah, but suppose it's not. Could be seconds before or after. Yeah. I mean, you could argue, oh, that's clear enough, I can work it out. But certainly seconds left is much clearer. But there's an even worse problem here than its lack of clarity. I mean, you could argue that's enough clarity. I personally would go for seconds left. What is it? Yeah, no, that's not about the choice of the name. It's just like it. What's that? Thank you very much. We've got to be consistent. We've already said days left. If you're going to have days left, you've got to have seconds left. Don't have days left and seconds. That's insane. At this point, if you went with second, you'd have to go back and convert the other thing to days. And then you'd have to have a good hard look at yourself and think, why did I think saving those keystrokes was good? Because you don't pay money for keystrokes, and this real estate in here is all completely free. The screen real estate's free. So fill it up. Don't worry about making things short. It will save you a split second in typing, but your time isn't going to be spent or lost because of your typing time. Your time is going to be spent and lost designing your program and then trying to fix it when it doesn't work. And anything you can do to reduce the amount of time it takes to fix it, because you make things clearer so errors stand out better, that's time well spent. So we're going to call it seconds left. Thank you very much. See, I'm not going to do the J. The J would be funny, and I don't mind doing it in the string, but here it would probably be annoying because, you know, what's the bet later on I'm going to declare something and use it somewhere else and I'll just get it wrong. So I could do int days left, and then I'm going to do what? Put them both at the top again. Int. Oh, thank you very much. Thank you very much. Uppercase S. Okay, now we're done. So, oh, we've got to return 0. Thank you very much. 0, does anyone notice anything about 0? But in the context of this code, what would we call 0? A magic number. Yeah, I mean, 0 is probably the normal, normally 1s and 0s are about the only thing people ever let you get away with putting in your code as magic numbers. But it's not ideal to return 0. I'd rather be returning something else. Exit success would be good. Exit success is something that's predefined to be 0. And now it's clearer because I'm returning success. I didn't have any errors. But now I have to include something to get that, and I wish I could remember what it was. I think it's stdlib. Is it stdlib? Let's try. Stdlib. I can never remember where it is. Because, of course, you only have to do it once. All right, now let's compile our code and see how it works. Well, it's not going to work because we've left that little bit of magic, wishful thinking in there. But let's see what error message it gives us. Thank you very much. What are we calling it? Seconds left? Well, what were we calling it? I can't remember. Countdown. Thank you very much. And I don't think I've saved it with the right file name yet. Let me save it with the right file name. Week 2 functions. No, let's call it countdown. All right. And now let me compile it here. No input files. Oops, sorry. Got to tell it what file to program. Compile countdown.c. Oh, it worked. Why is that bad that it worked? What haven't I done? I haven't done that bit. It's just very trusting. It thinks whatever I've created, I've declared a variable called seconds left, but I've never initialized it. What's sitting in there at the moment? Rubbish. Maybe if I'm lucky it'll be 0. Probably not. Rubbish. So it's going to print out rubbish. Let's see what it prints out. That'll be cool. Okay, let's go. So we're going to run it. /countdown. How many days to go? 0. Oh! I'm late. Okay, that is actually the code for me to explode. Luckily, I'm not looking at the last digit, so I didn't realize. So yeah, so you could say, oh man, you should initialize it. But I think, what's the point of initializing it? I'm just putting my own rubbish in there rather than random rubbish. The point is this variable contains nothing meaningful until we've somehow put the number of seconds in. Anything I type in now is just as meaningless as something random. Okay, so now let's convert it into seconds somehow. Can everyone see this is a perfect example of a top-down design for a program? I've written the program, it's done all the important steps, and I've just left some of the fiddly details till later on. As a programmer, when you sit down to write your program, like when you're sitting down to write the first assignment, it's those fiddly little steps that'll be freaking you out. And you'll be trying to start the program, and all the time you'll be thinking, oh, but how am I going to put the space between the millions and the ok? Or something, and you're going to be thinking about this really little details, and they're going to freak you out so much you're not going to be able to do the main big job. So just relax about the details and don't worry about them, and get to them at the end. Otherwise, you'll be paralyzed from the very beginning. So let's now do this bit of magic. How are we going to convert days into seconds? I could just type it in here now, or what else could I do? I could put it in a separate function. And this is what our general approach to computing is going to be. Whenever we've got a chunk of code that does just one job, take that chunk of code and put it in a function and give it a name. Name that function to be that job. And then when you want to do that job, you call the function. And if you ever need to do that job again, you've got a function written for it already. And it stops your main function becoming really large. The large main function is not an attractive thing to see. So now we're going to have to design our own function. I'm going to pretend I don't even know about prototypes, so I'm just going to write the function. What's the function going to be called? Days to seconds. What's it going to return? So it's going to be an int days. Am I going to do this sort of cute thing? No. All right, 2 seconds. All right, days to seconds. What's it going to take in? It's returning an int. What's it going to take in? An int. And let's give it a name. Days left. Okay, all right. Now our program's finished. Is it finished? No, because we've got to return something. Return 0. Now our program's finished. It doesn't do anything, but we're just going to check that it works, because this is a top-down approach. We don't stress out about all the details. Let's just check the infrastructure works. Oh, I haven't recompiled it? Oh, okay. Hey, let's see. Let's run that one again. See if we get the same number. No, it's a different number. Cool. I wonder if that's because of that space I put in, or if that's just doing random. Oh, wow. Something's happening behind the scenes there. So it really is just random rubbish. Can you see that? So now let's recompile it. Let's run it. How many whole days to go? 0. All right. Well, it compiled, but it didn't work still. That's all right. We've got a compiling working. So I need to up here. I need to say something like seconds left equals. Now I'm going to call that function. How do I call the function? Days to seconds. And what do I have to give it? Days left. So this says take in the number of days left. Hey, days to second function. Take in the number of days left, do some magical work, and tell me at the end one number. That's the number of seconds left. And days to second goes, okay. Where's days to second? He goes down here. Okay, I'm going to take in how many days are left, and I'm going to return 0. In this case, a number. In this case, the number 0. Did I save that just then? Let's save that. And now if we run our program, hopefully we'll get that there's 0 to go. Oh, implicit declaration of function days to seconds. Wow, what does that mean? Does everyone see that? It was an error message. It said implicit declaration. Implicit means it's not there. I'm assuming it should be there. That's what implicit means. Something that's not there that should be there. And you can infer that it should be there, but it's not there. So something's not there. Implicit declaration. A declaration's not there. So although I've defined the function, although I've said what the function does, which is return 0, not a very interesting function, I haven't declared it. I've never told the program, I've never declared that this function exists. I've sort of said what the function does, but I haven't declared that it exists. Does that make sense? So I've got to say that the function exists, and I'm going to do that up the top here. It's called a function prototype. I'm going to say, oh, by the way, there's a function called int. Oh, man. I'm too lazy to type it all. Let's just copy it up there. So I put this at the top. And this is saying, dear computer, there is a function called days to seconds. It returns an integer. It expects an integer. Don't worry about what the integer is called. That's irrelevant. Semicolon means the end. I've just alerted you that this thing's going to be coming. And the compiler goes, oh, okay. The compiler in C is a pretty stupid compiler. I don't mean to insult C. It's a lovely compiler, but it's stupid. And it basically starts at the top and goes down and never wants to go back. It's what we call a one-pass compiler. So it goes, la la la, comment, ignore, la la la, comment, ignore, la la la, comment, ignore, la 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 la. Oh, include? All right, I'll stick that whole file in there. Now I'll go through that file line by line. Okay, finished. Oh, now I'll stick that whole file in. Now I'll go through that file line by line. Finished. La la la, blank line, I don't have to do anything. La la la, oh, there's a function called days to seconds. La la la, oh, okay, there's a function called int main. La la la, oh, here's what it does. La 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 la, going down, going down, going down. And at some point it gets to here and goes, oh, this calls days to seconds. That's okay. Someone's already told me that function exists, so I'm going to be relaxed about that. And I'm going to be trusting and assume that later on someone will define that function. But if we hadn't put the declaration in, at the point it gets to here, it goes, days to seconds? What are you talking about? I never heard of days to seconds. And it raises an error called implicit declaration. Okay. So we've now declared it, so it should be happy now. Let's run it. How many days to go? 0 days to go. You have only 0 seconds left. I love that's my favourite part of the assignment. Yes? When you're counting down. Yes?
Sorry, for the system, do we have to declare the functions that way, or can we just place it above the main function?
Oh, put the main at the top. Yeah. Put prototypes up the top. Yeah. Main's your most important thing, so it should go up the top. It's like a top-down design. That's a good question. How do you order your functions? C lets you put the functions in whichever order you want. If I had put the convert days to seconds function above the main function, listen to this, because this is an important point. Mata. If I'd put the days to seconds function above the main function, then the C compiler would have already seen that function by the time I got to main. So it would never have stressed out when I tried to use it. So I wouldn't have needed the function prototype. Yeah? I only need the function prototype to give it advance warning. Oh, there's something I haven't done yet, but don't worry, it's coming. Does that make sense? So someone asked a very good question, which is, well then why don't I just write all my functions in reverse order? Why don't I use the most commonly used low-level basic raw functions put at the top and put main at the very bottom? And by the time I get to main, all the functions have already been declared? And my answer was, no, don't do that. Although that's legal C, and it will save you a line of typing, because by rearranging them you get rid of the function prototypes. Can anyone see why that's less clear? Yeah. Yeah, you have to pay attention. Oh, yeah, sometimes it's impossible to find an actual order that it'll work. Sometimes there's mutual dependencies. And you have to think very carefully about what order you put them in. And that's a pain, and we should never have to think. Everything extra thing we have to think about is using up some of our brain bandwidth that we want to be devoting to the program. Yes? When someone reads your code today, it's easier to read it as the main part. Yeah, thank you very much. Brilliant. What's your name? You said something really good yesterday too. Didn't you? It was him. Oh, okay. Oh, what's your name? Alex. And what's your name? Danny. Alex and Danny. Well done. Oh, Danny, were you the person I was making fun of for speaking an SMS voice? Yeah. You're taking all the vowels out. You know, I was just having fun. I wasn't actually making fun of you. Yeah. You might not have seen it. I wasn't having fun. Well done, Danny. Well done, Alex. So, yeah. Forgot what I was saying. Oh, yeah. The person reading although the compiler doesn't care, the person reading the program cares. When you read a program, it should be like a beautiful poem. I said that before. It should just make sense as you're reading it. It should be really clear. And you shouldn't have to go back yourself and reread any bits. You just think, oh, yeah, that works. Oh, that's right. That makes sense. If you do it put all the little things at the top and the main at the bottom, we call that building to a climax or bottom-up design. That's like, there's some little thing. This is like how maths works. There's some little thing, a lemma they're proving now. I have to trust they're going to need that later on. There's some other little thing. That doesn't seem to have anything to do with anything. I'm just going to believe that that's useful. And there's something else. What's going on here? I wanted to learn about. Oh, well, I'll just keep waiting. And you get to the very bottom, and then finally, the thing I wanted to do. And it uses all those bits, and it makes sense. Or the thing I wanted to do, but I can't remember because I've lost interest. I never even got to the end. So the idea is you start with the most important thing. This is top down, your main function. And then immediately underneath that, you write the next most important things. Then under them, you write the next most important things. So reading down, your reader straight away sees more or less what's happening straight away. And then they see the next most important and the next most important detail. And then the little fiddly implementation stuff, that's left to the very end. That they only have to read that far if they're really interested. Does that make sense? Yeah, cool. But it's completely legal C to do it both ways. But in this course, we'd prefer you to do it the other way. Okay, so it's all working. Everything's working except for the actual work. We haven't got it to actually do the calculation yet. What we need to return is days left times some number. What number is it? How many seconds are there in a day? 86,400. Cool.
Shouldn't we declare that up, find that up earlier?
Now, who said that? This is a very magic number. Now, the person that said it, who said it?
Up there.
Looks very clever. He's probably right. That probably is the number of seconds. But what if it isn't? What if you are making a joke? Or you're really clever, but you misheard what I was saying? Or someone changes the definition of a day somehow, or something like that. What if this number's wrong? And what if it's like controlling a piece of network routing software that's being used in a remote operation out the back of Alice Springs, where a doctor in Sydney is operating remote control equipment to do heart surgery on someone, and suddenly your program goes, because you got the number wrong. It probably isn't. Can everyone see? I believe that is probably the right number, and I have no idea what's the right number. But I believe it is the right number. I have no doubt in my mind that it's the right number, yet I don't think we should write it down, even though I don't think it is wrong, because it might be wrong. So what should I do better? One thing I could do is at the very top here, I could say hash define seconds per day 84. Was that it? Oh, already. 1 0 or 2? 2. Okay. So we could do this. Now this is looking heaps better, because now Berjay, it just never stops being funny. I like that. Look, we make fun of Vikings and the Norse people, but they've brought us IKEA. I was going to bring like an Allen key along. Yeah. So, you know, it's really cruel to make fun of them, man. And Nokia, as we like to call it. Okay, so how many whole days to go? Suppose there's 0, that works. Suppose there's 1, that works. Suppose there's, how many days do you really have to go?
Negative 14.
14. There you go. Oh, 1,209,600 seconds to go. Cool. All right. So you got lots of time, so I reckon you don't have to start right now. So that's okay. If we had to say how good that program is, I'd say that program's okay. But I wouldn't say that that's a beautiful program. How can I make it better?
There's a problem like stylistically having two variables holding the same information.
Is a problem having two variables holding the same information? Yes.
Days left and second left they're like the same thing, but they're in different units.
Oh, I see.
If one changes and the other one doesn't change, then you have two different.
Yes, you're right. I mean, there is this relationship between them, and I'm having to maintain it actively with the function. And that's a really high-level comment. That's probably a comment better in a second-year course or something like that. Because in C, we have no way of maintaining relationships other than by actively invoking functions. Okay, so.
But I'm just saying that instead of saying seconds left.
You're saying don't store it anywhere, just convert it as you're printing it, sort of thing. Yeah. And which would be fine. But and that's a fine observation. The reason I want to steer away from that is A, it's not the biggest glaring problem, but it's a really big problem. But B, that enters into an interesting range of conversations. What Stephen's saying is, once we've got something that records how many days are left, and we want to display how many seconds are left, it's not really a different piece of information. It's the same piece of information, just expressed differently. It's never good, really, to store the same piece of information twice, like we're doing here, because the two versions can move out of sync somehow, and then we're doomed if we think they're still related. It's better just to store it once. And that's completely correct. The reason that you might actually want to do the conversion, it's such a small example, it doesn't happen in this one, is if it was an expensive conversion to do, and you needed to do it frequently, you might want to cache the results, you might want to store it. Or if the number of days left was an integer and the number of seconds left was an integer, and we were actually going to be decreasing the number of seconds left throughout the day. Yeah, might. So this might just be initializing seconds left at the beginning of the day. So I could propose scenarios where it makes sense to do that. But yeah, that's a really good observation, that redundancy is always bad. Doing something twice is bad. Storing the same things twice is bad, because you can be sure the two things are going to move out of whack and then you're completely dead. Because you'll look at one of them and it'll seem right. And you've got to look at both of them to spot it. But there's a much more basic thing I wanted to say than that really good observation, which is seconds per day. There's still a problem with seconds per day. I've given it a name so it makes sense now. We know what it is. I've typed the number at the top, so if we make a mistake, we can at least fix it and it'll get fixed everywhere. But I haven't really addressed the underlying problem, which is I'm not really sure that that's the right number. How can I be sure that that's the right number? I should just damn well calculate it. Who should calculate it?
Computer.
Yeah, the computer might be stupid, but it never makes numeric mistakes. I might be a diabolical programmer, or I might not, but I always make numerical mistakes. So let's each do what we're really good at doing. So it really, what is it? It's 24 times 60 times 60 I'm going to put it in brackets for reasons that will become apparent after the tute or lab. Does that look cool? What do you think? It's better. I reckon we're at a B level now. This is like a B quality program. We've moved from an F to a C to a B. Yes?
I was going to say maybe you should, instead of returning then like an equation, you should assign an equation to a value and then return a value to make it neat up. Down the bottom.
Oh, down below. Assign it to a value and return the value. Oh, yeah. Good point. We'll get to that. But let's just deal with this problem at the top. There's also a problem at the top that I'm looking at. What's the problem? What have I done now?
You've assumed the length of an hour.
I've converted one magic number into 3 magic numbers. Now, these magic numbers, I'm much more likely to get these right. But I still don't know really what they stand for. So notice there were two, when we went to putting this at the top, the first thing it told us what it stood for, and now we're dealing with getting it right. And I've converted it to some other things, but I haven't said what they stand for. So how do you know it's 24 times 60 times 60? Well, probably you can look at it and guess what those things are, but what should you really do? You should define them. You should say it's hours per day times, days, minutes, but I can't even spell minute. How do you spell M-I-N? Min. Min per hour. It could be minimum. Yeah. So I should call it minutes. And I should call this what? Sex. Sorry. Min. I don't want it to go on a new line, so I might be in trouble. It might be too long. I had to put it in brackets. That's all looking good. And I better, before I do that, because it's a one-pass compiler, I better define the other things above. Define. Oh, it's so tedious. Can you see? But it's better. Hours per day, 24. Because if the number of hours in the day ever change... Yeah, that's right. At some point, you got to stop. That's right. You can go to a ridiculous extent. But I reckon we've stopped at the right level, because I reckon the things we're assuming, in maths, this would be called going back to the axioms. What do we assume are the axioms? If you look at how math does geometry, like Euclidean geometry, they go back to 3 basic axioms that are so basic, or 4 actually, 4 or 5. Euclidean geometry has 5 axioms, or 6 next time I think about it, but it's 5, And they're so basic that everyone agrees with them. 2 lines will either be parallel or intersect in a point. 2 points define a unique line. Every line can be extended infinitely in all directions. The axioms are the things that no one quibbles with. Now, I should say some people do quibble with the axioms of Euclidean geometry, just like you could quibble with the number of hours in the day or minutes in the second, something. But that's the appropriate point to take it back to in your program, to something that's so basic that everyone's going to agree with it and it's obvious. So someone looking at it's going to go, that's really simple. I can't believe I can't even believe you wrote that. That's just really trivial. Yeah. Yeah, you could add a comment, and that's almost as good.
Only almost?
Almost as good, yeah. Like a famous programmer once said, I was privileged enough to be with him, Mark Lauer, brilliant guy, and he said to me, you know, every program is like an apology. Every comment is like an apology. Every time you write a comment, it's like saying, I'm really sorry, my program is so opaque and hard to understand. Here's what I'm really trying to do. And his theory was the best program in the world had no comments in it at all. It's just self-documenting. You read it, it makes complete sense. So sure, if you ever do anything really confusing and complicated, put in a comment to explain what you're doing, and that will make it better. But even better is not to need the comment if your code is just so clear that it's self-commenting.
Surely it's not worth the extra time writing the extra 3 lines when you could just write 1 comment.
Oh no, but how long is it going to take me to type those lines in?
Significantly longer than just writing 1.
No, what's that? When it gets more complicated, we're still going to, yeah, that's right. But we're still going to take it to this level of basicness. So I'd still want to defend this level of basicness. It's because it will take us a few seconds to type it and it'll use up a few lines, but it will be right. And 99 times out of 100, if you didn't do that, you'd be fine. And 1 time of 100, if you didn't do that, you'd be stuffed. If I was checking your code and it was a comment and I had to check your code, I would have to stop, get out my calculator and multiply those numbers because I do not believe you've done that multiplication. If the program does the multiplication, if I'm reading the comment, I don't even have to stop and check. I just keep going. So you could put a comment saying there's 60 seconds in a day, 60 minutes in a day, and think, you could say that.
But you could just put a comment and say that these hours represent hours per day, meaning per hour.
Yeah, you could. You could. You could. And really, we're quibbling about small things at this point. But I would go that extra bit. My approach to programming is your natural inclination as a programmer will be to type less. And that is a false economy. And that if you cut one corner and then you cut another corner and you cut another corner, after a while your code starts becoming cryptic. And you should just be ruthless and explain everything to the same level of simplicity. You don't have to do it, but that's my take as a programmer. Yes? Someone has something to say?
Yes, but if you have lots of these calculations being done throughout the whole program, let's say it has to do it 500 times, would it be better to have just a constant instead of a variable because they'll have to pull the variable out?
Yes, yes. There's a bit of work we're making the computer do here. It's having to multiply 3 numbers. But it's doing that at compile time. Oh, no, it's not. No, it's doing that at runtime. Oh, is it doing it at compile time? Let's have a look. It's doing it at runtime. Yeah, so if we use this, if this was a really time-critical thing, then, well, okay. We've now reached the second sort of interesting question, which is, you're doing something, Richard, that's going to cost us a little bit of time. We could save a little bit of time if you didn't do it. So perhaps we shouldn't do it. And certainly that question never has a clear answer. Sometimes doing a bit of work and wasting a bit of time is really bad. And sometimes doing a little bit of work and wasting a little bit of time is irrelevant. The trick, the Zen trick when you're writing a cool program, when you just sort of understand everything, is you've got to work out when it matters and when it doesn't. I can't think of any case that this would matter. But certainly if this was inside a really tight inner loop that was being executed 1 billion times, I would pre-compute the value and store it outside the loop and use the value over and over inside the loop. But I can't see that that's going to happen. With the small decisions like that, which we call optimizations, often the compiler is smarter than the person writing the program. And you can tell your compiler, oh, compiler, can you optimize this for me? And it'll think of all these little tricks and move things outside of loops and do all sorts of stuff, and it will save you a few % in speed up, or it might even double the speed of your program. I claim the best person to do optimizations, general low-level optimizations like this, is the compiler, because it's very clever. And my job is to write the program so it's clear and correct. Once I start cutting corners to make things a little bit faster, I'm also making my program less clear. And for me, that's the most deadly thing. So, for example, a couple of years ago, we normally, actually, though I don't know if we're doing it this year, I don't think we are, we normally have a race where all the students and tutors have to, in the final assignment, you have to write a program that does something. And we say for brownie points, not for any marks at all, you know, maybe it has to deal with cases up to 50 big. And we normally say at the end, a challenge. We're going to pump in something 1,000 big to this and see how fast your program is. And we'll have a race and see who's the fastest. And I put in a solution, and the students all put in solutions, and the tutors put in solutions, and we have a very, very fun race, and it's a complete hoot. And we have lots of lectures about how to optimize your code and make it faster. We're not doing it this time, but maybe I should still have a lecture on speed-ups. Because the amusing thing is that most of the students that are trying to speed up their code make lots of small, almost irrelevant speed-ups that give them an extra 1 or 2%. And the person that wins is normally the person that has a really good idea that lets them be 1,000,000 times faster. So there's someone here who's sped up their code and got an extra 2% by doing this or that. But there's someone over here who's just, see, already, I owe you 4 Mars bars, I'm not liking you guys as much. Someone over here who just has one idea and it makes it 1,000,000 times faster. And the really pleasing thing to me is whenever I look at that smart student's code who's 1,000,000 times faster than everyone else, he does everything really neat, or she, he or she, should say, because 2 years ago it was a she, awesome woman, Libby. She does these amazing things, but her code is really clean. It's so clean and nice and precise. And sometimes she'll even do things the long way around, and she's wasting a bit of time. And she'll put a little comment in saying, I know this is costing me a few cycles, but it seemed cleaner this way. And it's someone who's throwing away a bit of speed to be clean, because she knows the important thing isn't making everything faster, it's picking that one bottleneck thing that's the key thing and making that fast. And making it, like, suppose you're running Windows and you wanted to run a burglar alarm control system and you wanted to make it a little bit faster. Already, just give up. Don't use Windows, you know. Like, there's no point whether you make it 1 or 2% faster in Windows when you could run it 50 times faster by using some sort of other operating system or something like that. I'm just making fun of Windows. I'm sure Windows is not 50 times slower than other operating systems. Okay, all right, now how are we going for time? We've got a little bit of time. Mins per hour is 60. Oh, this clock's not right? No, all the clocks look right to me. Get rid of the S, thank you very much. Yeah, I think change the other one. Thank you very much. Thank you. Yeah. Thank you to everyone that spotted that. Now, I'm not sure, maybe I'm going to have to defer to a C guru here. I want to split my hash define over 2 lines. Is a continuation character going to work?
Yes, backslash.
So the preprocessor obeys continuation?
It sure does.
Okay, cool. So if you want to break it over 2 lines, put a backslash in. Yeah, I've got to get back up to that line. It's just the way it's working. It's not working. If you end the line with a slash, it's as though it never really ended. It's as though it just kept on going. Mins per hour, secs per min. Hours per day, mins per hour, secs per min. And secs. Did that sort of answer your question? So your observation's spot on. And I don't want to go into the detail in this case because we don't have a real application. It's hard to weigh it up. It's not a clear-cut decision. It's not an always do it this way, always do it that way. It's a work out what's important. And if it's important, do it. And if it's not, don't do it. And be aware of it. But don't fall into the trap that I think a lot of people fall into when they're starting off programming, thinking, I will make every little bit faster, and overall that will make everything faster. Because along the way, you're making a whole lot of decisions to trade off speed for clarity. And I think clarity is the most important thing. If you want to make it 10% faster, buy a 10% faster computer, really. Because the thing that's going to kill you as a programmer is your code is going to get too complex to work. And you're not going to be able to understand it or maintain it. So always go for clarity, never for speed. Yes? Tom. Is it Tom? Yes.
Wouldn't it be a good idea to make it like that?
Yes.
Explain everything, and then give it multiple revisions and make it more and more cryptic and more and more cryptic?
You could, but then if Tom's question was, why don't we give this basic version as like a comment on the program, and then also create more and more cryptic but faster versions related to this version, so we get both speed and clarity. And that would be fine, except if you remember what Stephen was saying before, we've now got the same thing stored in lots of different ways. What happens if you spot a bug in one of those versions and you want to fix it? You've now got to fix it in all of them.
I was thinking that I'd like to just have like a second version of it, which is like, once you've finished it like that, you
Yes.
can make it
Oh yeah, okay. But he said, what he was meaning is once we've finished it, can we do that? And what I'm going to say is, that land of once it's finished is a land we never get to visit in computer science. We all long for it, you know, and one day this program will be finished and we'll all be free. And everyone goes, yes, but we never get there. It's just a scam, it's a con. Okay, nothing's ever finished, nothing ever works. You always got to keep working, just making it better and better. So whenever you write a piece of code, even if you think it's finished, I rip out bits of code I wrote 20 years ago. At the time I thought they were finished, and suddenly I think, oh, I could use that for something else. I need to do that job, I've already solved it 20 years ago. So your code, and it's not just me, I post my code, other people use it, that gets embedded in others, and you know, it goes on. So code just always has a life of its own and lives long beyond your expectations. Code is never a static dead thing, it's a living thing that constantly is being reused. Yeah. Okay, now, I saw there were some hands over there. Can I get to you, do you mind if I get to you, unless it's really quick, can I just do...
I just wanted to say that in my opinion, that it's actually harder to read.
Oh yeah, there's a trade... There's like, this is the last thing I'm going to say about style, but it is important to address style. When you make things simpler, if you make them too simple, it becomes really annoying. So when you get a textbook and they explain something at such a basic level that it just pisses you off and takes 900 pages to say one simple thing, sure, they're saying it really clearly, but the communication fails because you get annoyed and give it up. So what these guys are saying is, for them, this is frustrating them because It's too simple. Now let's look at the disadvantages of writing it this way. It's longer. Means less is on the screen. My brain can only hold a certain number of things in it at a time. If the program's longer and I have to scroll up and down to work on what's going on, that's just, you know, wasting brain space and dangerous. So longer isn't so good. There's a slight downside to being longer. Also, there's something called an idiom, a standard way of programming. And once you're used to it, you just see that idiom happening all the time. So there's some shortcuts that everyone uses that are unclear. But because after a while you get used to that idiom, it's safe to make those shortcuts because you know what they mean and everyone knows what they mean and everyone's seen that code 100 times and that's completely fine and safe. But can I say that this fine line between trading off clarity and simplicity is one that's very difficult, and virtually never do I see students erring on the side of making things too simple. So I'm trying to make things really simple. Possibly you could make it more complex and it would be okay. Possibly that would be okay. But I've got to say, and your tutors will be marking your code closely, so speak to your tutors about it. All your tutors care about is clarity. But when it comes to a judgment call, and people sometimes go one way and sometimes go the other, it's very rare that I see people going the wrong way. Like, I like longer variable names. Same thing. If your variable name is too long, it's a stupid name. And it takes up all the line and you can't put enough in and it's just wasteful. But yet, I never see students with variable names that are too long. Well, sometimes I do. Normally, they're people trying to make them shorter. And they make it err on making the size too short. But of course, if I say longer is better, then I'm not being strictly right, because it's a balancing act. And if you see some Microsoft code, when they use the Polish notation for variable names, they're ridiculously long. There's no way anyone can understand any of that code, because like, you can only see one page at a time. That's one variable name. You want to see what happens next, you've got to go to the next page. That's a complete waste of time. So yeah, and you could take this to a more ludicrous level. You could have milliseconds per hour, milliseconds per second, and nanoseconds per millisecond. And you could go to a ridiculous extreme. It would be ridiculous. You've got to draw the line somewhere. I'm deliberately drawing it really simple here. No one will ever penalise you for being too simple, unless it's massively too simple. The danger is you'll go too far. By the time you get to second year, you'll be making these trade-offs all the time. Ask your tutor, they're a wise person. A lot of your tutors are professional programmers. They've all done amazingly well in programming and won programming competitions and done amazing things, and they're awesomely good. So ask them their opinion and debate it with them, and they would love that. There's nothing more a programmer loves than someone sitting down and debating with them about style. And sometimes in my old days when I was a programmer, the boss would walk by and I'd be sitting at my desk scratching my head. And he'd say, "You've been sitting there for 10 minutes scratching your head, that must be a hard problem." I'm saying, "Yeah, I don't know if I should call it days per minute or..." And he's going, "What? You've been thinking 10 minutes for a variable name?" And I'm going, "Yeah, it's really hard to get a right variable name." He wasn't happy. But when you get it right, your code's just magic and it works. And someone that goes in like a cowboy and knocks something up quick, tomorrow we find the code doesn't work and the client's looking at it and it's embarrassing. Or it's a mess. Or next week we want to extend it to handle another case and no one can understand it, so we have to throw it out and start again from scratch. That happens a lot too. So yeah, get your code right. Err on the side of being too simple. Everyone's going to forgive you for that. Secs per min, 60. Now seconds per day, boom, 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 boom. Whew. Let's go. Let's compile it. That took 20 minutes to do. Normally it wouldn't. Backslash and new line separated by space. Did I put a space after the backslash, did I? Let's get rid of that backslash. There we go. So at the end, after the backslash, there should be nothing. Nope. No. Oh, what happened there? Oh, the old version, the last time I compiled successfully is what's left. Let's compile it again. Let's run the new version. Countdown. How many whole days to go? 1. Hey, you were right. Well done. Okay. All right, does everyone see? So we've written a function, we've got our function to work, we've made nice code, blah, 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 blah. In the few remaining seconds of the code, what have we done? We've done our own, I haven't done our own .h files, haven't done extracting digits, haven't done traps and pitfalls, haven't done practice times 3. Yeah, I haven't done a lot. We spent a lot of time looking how many seconds were in a minute. And answering questions about it. And you know, I'm completely happy with that, because I think they're really important questions. Practice times 3 I want to talk about, because the next student was talking to me. And he said, "Oh, don't forget to say that, because it made a big difference to me." When you're sitting down to, a lot of you, remember we've got the ABCs? Now the C's can already program and they're just itching to learn like extra stuff. But the A's are just coming to terms with learning how to program, and they've got all these mental obstacles in front of them because things aren't going to work and they're going to get depressed and they want to master some skills and they haven't got the skills yet and they can't do it. How are they going to get to this point of mastering this stuff? It's going to be 4 weeks for them to get it. And it's going to be hard. How are they going to do it? Well, if you wanted to learn the piano, would you read a lot of books about pianos, come to a lecture and hear me say amusing things about playing the piano, and watch pictures of people playing pianos? Would that teach you how to play the piano? If you're amazing, it would. But for a normal human being, how are you going to learn to play the piano? You're going to play the piano. You've got to do it. It's sure, you've got to read the books, and it's interesting to hear people and learn about the piano, but at some point, it's not going to happen unless you play it. Can you play the piano a little bit, and then you'll be good? No, what do you need to do? Is practice enough? No, you've got to practice, practice, practice. So my advice to you guys is, I reckon if you're a new programmer, and on top of all the other work you're doing, you've probably got, hey guys over there, shh, 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 shh. Oh man, 3 times. Shh, 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 shh. You gotta, I reckon, practice about 3 hours a week on top of everything else. And that's just sitting down fiddling. So when we do something in lectures, go home and try it out, and then try variants and practice it. And just go home every night and practice it, and practice, practice, practice. If you didn't do 3 hours practice last week, this week you should be doing 6. Over the break, do 6 again, 12. And just practice all the time. Don't leave it to a big rush at the end, that never works. A little bit of practice every night. Do 20 minutes a night between this and that. But you've got to practice, practice, practice to learn these skills. You're now about to leave me and I won't see you for a week. Because 2 weeks, for a while. Yes, hey. Escape. But, shh, during that time you're going to be writing an assignment. Oh man. So let's talk about the assignment. Oh, haven't we got, I think we've got 5 minutes. Is that what you think, or 4? Yeah, shh, shh. So stop rustling. Shh, 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 shh. How are you going to write the assignment? I think your biggest problem in the assignment is going to be getting started if you've never programmed before. If you have programmed before, your biggest problems, your personal challenge is probably going to be just try and write a really clean program. And when you think you've written it as clean as you can, write it cleaner. You think it's clean as you can. And clean means simple. So you just want it to be at the end the simplest, clearest, plainest program you can write. And when you think you've got it right, go away from it for a day and come back and make it better. And by the end, it'll be so small, so clear, but not terse and cryptic. It'll just be beautiful. Small, fast, efficient, correct, lovely. But don't give up. Every time you think you've got it good enough, it's not good enough. Try again. But if you haven't ever programmed before, shh, don't worry about any of that. Just write it clear, and you'll be trying to do that anyway, because that'll help you. If you've never programmed before, here's what I think you should do. Think about the problem a lot. Work it all out on pen and paper first. I did the assignment a few days ago. It took me, and this is not a brag, because I bet my assignment's wrong, it took me about 4 hours to do it. I spent 2 hours writing it out on pen and paper first. Thinking, how's it going to work? And just drawing diagrams and writing it out. And I wrote all the code out on pen and paper. I then typed it in and compiled it. There are a few little errors. I fixed them up. I ran it, and it appeared to work. How did I get to that miraculous state? Am I a genius? Am I the best programmer in the world? No. Here's how I did it. I just practiced a lot more than you guys. Here's what I did. Before I started it, for about a day, I did nothing but think about it. I didn't do typing or anything like that. I just thought about it. So I was in the car, I was thinking about it. I was in the shower, I was thinking about it. Now, I don't know anything about Viking numbers, so what was I thinking about? What's that? How's the number system work? How's the number system work? I was thinking about English, yeah. I was thinking, I know English really well, so I was thinking, oh, how do I say English numbers? And I'd just scribble it down. Occasionally I'd say to my wife, good grief, say this number, will you? And she'd say it, and I'd say, isn't that weird? I would have thought you'd have said this, but it's that, isn't it? And we'd both look at it and go, who would have thought English had that crazy rule in it? And I'd be sitting down and I'd be thinking about it. And I just thought about it for a long time. And by the time I sat down to write the program, I had already thought about it a lot. So I don't think sitting down straight away typing is going to help you. The advantage I had over you is I already knew how to program in C, you don't. So keep doing your practice and your exercises and all the things to learn about how to program in C. But in terms of tackling the problem, think about it a lot, solve it on pen and paper, write your code out by hand first, I suggest, rather than typing it in. And then when there's a problem, what are you going to do? Fix it. Yeah, fix it is a high-level solution, but in concrete terms, how are you going to do that? Because we're always going to bump into problems. Details, how do we fix them? All right, so here's how I've solved problems when I see problems, because you will get problems. Step 1, make the program work for a small case first. And we've designed the assignment so it's easy to do. Just get it working for the first 10 numbers. Then get it working for the next 20 numbers. Then get it working for a bigger one. And don't worry about the next step until you've got each step before that perfectly done. And that way, when you hand it in, even if it's not finished, you'll get a lot of marks. because about half the marks are for easier cases, and then some marks are for harder, and some marks are for harder, and only very few marks for the very final, really elaborate, complex cases. So do it small and increase the scope each time. So you're working on a small scale problem that's much less daunting, and you hit a problem. How do you solve the problem? Well, it's a mental thing. As soon as you hit the problem, you've got to be mentally blocked and you're not going to know how to proceed. When you see the final answer, 9 times out of 10, it'll be something really obvious and you'll be cross you didn't see it. So you are going to be the problem here, not your C ability. So get lots of sleep, be relaxed and calm, never get angry. Setbacks should just make you happy or calm. Just be manana about them. Oh, it's not working, that's okay. Play happy music, speak to your friends, still see your boyfriend and your girlfriend and eat chocolate and all those things that make you happy and stay in a good frame of mind. And then be systematic. So you've got a problem, it's not working. Get a logbook out like you're a scientist. Shh, shh, shh. I've got like 20 seconds to go, guys. Shh, shh, shh. Get a logbook out and say, I tried this, it might be this or this or this. I tried this, this is what happened, and record systematically what you do. And if you can't get it to still work, go away and have a break and come back to it. Mail your tutor, show it to friends, seek help everywhere you can, but be calm. All right, good luck everyone. See you in 2 weeks.
Can I just ask, for curiosity's sake, about how many lines do you